Hi, welcome to A Long Road Home. My name is Aaron Frost and I'm the lead programmer. Rylan Krebs is handling most of the artwork. This is the second month of development, and we are currently split 50-50. I do the code and he does the art, but we make the game together. So the idea is that a player is stuck on an infinite highway. We decided to go with a tile-based system to create the highway, where each tile fits together like puzzle pieces. Using pseudo-random number generation, we can choose each tile at random. Each tile contains an array of what we call plots. Plots are places where structures will spawn. Plots have a size which helps to determine what structures can spawn on them. There is also a structure type system which helps the level designer choose what types of structures can spawn on certain plots. These are pretty complicated weight-based systems, so I won't go into detail. But for now, I can show you the prototypes for the current plot structures. Gas station, apartments, electrical, and junkyard. These structures can be found spawning along the highway, and will soon contain loot spawns where the player can gear up. Speaking of gearing up, the player can interact with the environment through a slot-based inventory system. Icons display the items that the player holds, where the primary and secondary slots are for the equipped items. The inventory accommodates swapping, splitting, and stacking, as well as dropping. Right now, you can only interact with 3 things: your car, your gun, and the ammo. 4 things if you count shooting the dummy. All functionalities you see and hear are programmed by me, including the character controller, which uses quite a bit of vector math to handle the slopes. For the car, the orbiting camera required me to learn a lot about quaternions, and I still think that they don't make any sense. A Long Road Home's a survival game, and who'd want to play a survival game that doesn't have a day-night cycle? Achieving this wasn't hard. 2 directional lights that represent the sun and the moon set opposite of one another. All they need to do is rotate. In light of this, I wanted to make the game more visually pleasing, and I think color palettes are really good at doing this. The problem is, in a 3D environment, how do you control the color palette that the player sees? I wanted the player to feel as if they're looking at a beautiful painting from every angle. So, taking inspiration from a game called Firewatch, I dove headfirst into creating a stylistic fog shader. This would be a post-processing effect that would take the distance from the camera to each pixel and use a gradient based on that distance to determine what color of fog gets returned. Me and Rylan had never created a shader using anything but a node editor, so there was a lot to learn. But to my surprise, I figured it out very quickly. There was just one problem though. For some reason, this awful banding would occur when using certain gradients. I assumed that this had something to do with the color space, as color banding is typically the result of a restricted color space, and I was actually right. After a lot of frustration, Rylan figured out that it was the import to Unity causing the banding. Awesome. Anywho, the hard work paid off because the results are stunning. This allows us to create special color palettes that we want the player to see. I went farther to integrate this with the current day-night cycle by sorting the gradients into groups. Depending on the time of day, the gradient will be randomly selected from these groups in such a way that we can choose all of the different appearances for the sunset, day, and night. As the time passes, the gradient cycles. There are way too many systems in this game to feature in less than 10 minutes, so the last mechanic I'll be featuring for this video is the weapon recoil system. Everyone knows that when you shoot a gun, it propels itself upwards. Minigames simulate this by creating recoil patterns for each weapon. This way, the player can learn and practice the recoil pattern in order to master the gun. We decided to implement this sort of recoil pattern by using a feature in Unity called animation curves. It's pretty complicated behind the scenes, but essentially the designer can swiftly create recoil patterns for each gun by simply using a mathematical curve. Watch how the AK recoil follows the curve. In addition to this, we've created an accuracy system, so that the more you spray the weapon, the larger the aimcone gets. The bullets will always land within the aimcone, but since we square the value, it's more likely to land in the center of the aimcone than the outside. In this video, I've barely scratched the surface when it comes to the game's systems and features. If you're interested in taking a more in-depth look, stay tuned as we'll be releasing more videos on the game. That said, there are also many features that we're currently working on, and those are multiplayer/co-op compatibility, saving, AI, loot spawns, biomes, and much more. I encourage you to join the Discord to stay up to date with the game. The link's in the description. Thank you for watching.